Like we talked about, magnets were first used for navigation. And it was very useful because when you're out on the ocean, everything looks the same, right? So the ability to determine which way is north, south, west, east was very useful for navigators. Here's what's weird. The north geographic pole of the Earth, I'm going to zoom in here, where Santa Claus and the elves are taking a rest after delivering all the presents here, yeah, is actually magnetically south. And the south geographic pole, down here in Antarctica, where the penguins are dancing around with their happy feet and all that good stuff there, is actually magnetically north. Huh? I don't get it. Well, if you think about it, it actually makes sense. In order for the north end of a compass to point towards the North Pole, then the Earth has to be magnetically south, because opposites attract, likes repel there. Maybe another way to help you visualize that is this little computer simulation we're going to look at later on. It's one of the FET simulations from Colorado here. So if you think about it, normally, if you have a bar magnet, by definition, the north end of a needle will be attracted to the south pole of this bar magnet here, right? And then it'll be repelled. And then the way you get the magnetic field lines is you just take this compass and you move it around and you can plot it. And this is a little lab we'll try tomorrow where we'll try to draw out some field lines there to kind of picture it there. Now, normally, a compass needle would line up with a bar magnet because it's the closest thing, so the field is the strongest. But if you don't have a bar magnet, it would just line up with the Earth. And the only way for the north end of a compass to point to the North Pole of the Earth is if the Earth's magnetic field is magnetically south at the north geographic pole. It's somewhere in northern Canada. And then in Antarctica, it has to be magnetically north. Now, here's another weird thing. What if you are exactly at the North Pole here, or exactly at the South Pole? What would your compass do? Would it be very useful? No, it would just point what? So some people think you get the Jack Sparrow effect. Maybe, if you're walking around, right? Just the compass points randomly to your heart's desire, whatever, right? So, but really, it would just, if you're exactly on the north or south magnetic pole, it would just point straight down. Because in real life, the magnetic field is three-dimensional. And if you get a lot into navigation, you're sailing, you're in the Army, you do stuff with boats, Boy Scouts, you have to account for what's called magnetic deflection. As you go more north in the hemisphere, or south in the hemisphere, you have to adjust your direction because of the fact that the magnetic field is 3D. The other thing that's weird is the magnetic poles drift around, and they even reverse direction. About every 5 to 700,000 years, the poles completely shift. North becomes south, becomes west, becomes east. Your compass starts pointing all over the place. And there's proof of that if you look at the geologic rock structure in different parts of the world there. So one theory is there's hot lava currents that flow through the core of the Earth there. And because it's super hot magma, it's electrified. And a moving electric current generates a magnetic field. Therefore, the magnetic field of the Earth is shifting over time. In fact, let me show you a little animation of that. A little cheesy animation, but it shows you how over time, since the 1830s, when we started tracking where the magnetic pole of the Earth is, it's actually going and drifting into the northwestern part of Canada. Is this Yukon territory or Saskatchewan, where Bigfoot's running around? Something like that. So what's weird is the magnetic poles of the Earth are constantly shifting and drifting over time. And in fact, one thing we're worried about now is the magnetic field of the Earth is actually weakening, and there might be holes in the magnetic field of the Earth, which is actually good or bad if we lose our magnetic field. It's very bad. Why? Because we can't use compasses anymore? Well, maybe, but what's the huge problem? Anyone know? Yeah, it protects us from the sun's radiation. So really, the Earth's magnetic field is awesome and acts as a shield. And also, for navigation, it is useful. This is really cool. I got this from a pilot I met one summer, and he gave a little talk on navigation. This is an actual North Atlantic piloting chart that they get before they plan out a flight. And even though there's all this high-tech equipment, they still do it old school. Protractor, ruler, calculator, a compass, just in case all the electronics fail. And what's funny is because the magnetic field of the Earth shifts so much, they have to literally get like an updated map, I think every month or so, of the magnetic field lines of the Earth there. So I thought that was kind of interesting there.